Hello everyone, welcome to my channel. This is the introductory video for the series of embedded programming for SIWG917. In this video, we will be majorly discussing about the features of the SIWG917 and details of the wireless pro kit and radio board that we are going to use for developing applications for our target microcontroller, which is SIWG917. So without any delay, let us delve into the details and features of SIWG917. So coming to the details and features of SIWG917, it has got ARM Cortex M4 processor with FPU subsystem up to 180 MHz of clock, and it has got rich digital and analog peripherals as well. It has got major support of Wi-Fi 6 with single band 2.4 GHz, and it has got Matter support, which is a important thing for today's IoT devices. And apart from those, it has got two processors. One is for network and one is for matrix coprocessor. So here you can see, here you can see ARM Cortex M4 is dedicated for peripherals and application related processing, whereas network processor runs the wireless and networking stacks on the independent threads. So it has got three processors, and here you can also see that matrix vector processor is also there. Matrix vector processor, you can use it either for convolution neural networks or any running any neural networks on it. Apart from that, it has also got onboard memory, which is 8 MB flash option is there, and it can be external flash also up to 16 MB. And apart from that, it has got a PSRAM option, 8 MB and 16 MB variant again. It has got a voltage range of 3.3 volts, and also it can be operated in dual supply like 3.3 and 1.8 volts. The operating temperature is -40 to 85 degrees centigrade. So it is like commercial use only, consumer use for consumer goods. And coming to the block diagram, it has got two types of peripherals. One is for ultra low power and one is M4 peripherals. Ultra low power peripherals, you can use them when your device is in thumb mode, like low power mode. So it has got real-time clock in it, and also ultra low power GPUs are there. It has got SSI, I2C, I2S, UART, and it has got digital to analog converters and oscillators, analog to digital converters. It has got timers, and also it has got comparators, and touch sensor also is being embedded in the ultra low power peripherals only. It has also got SRAM support. Apart from this, in the M4 peripherals, which is not ultra low power, it is like high power peripherals. Again, it has got the support for I2C, I2S, GSPI, and USART, UART, and many other popular serial communication interfaces. It is also providing a good security, like it has got AES, cyclic redundancy check. It has got SHA for encryption and RSA for encryption. So these things you can use when you are using this chip for your IoT device, so that your IoT device will be secured. And coming to wireless stack, it is supporting Wi-Fi, Bluetooth, and also 2.4 GHz normal receive and transmission. And apart from this, in power management unit, it has got DC to DC converters, low dropout voltage regulators, and watchdog timers. And it has got VBAT GPIO, means you can monitor the level of the battery using one GPIO pin which is being given by them. And coming to host peripherals, it has got SDIO, UART, and HSPI. So these are some basic features of the SIWG917. If anyone are willing to delve more into this, I'll drop the link for this document in the description. You can go through it. And next thing, coming to the details of the board that we are using. So for this series, we will be using BRD4338 along with BRD4002. So the black color thing underneath the small board you are seeing is known as BRD4002, which is WPK board, wireless pro kit. And the thing that you are seeing, like which is pushed and pressed onto the board, is nothing but BRD4338. So this is like plug and play. That BRD4338 is removable. You can remove it and place another microcontroller radio board if you have. For example, you can use a EFR series board. So the base board won't change, only the top board radio board will change. You can still develop the applications using the base board. So the baseboard has many features, like it has given Ethernet interface It is supporting J-Link through the C-type port, and also it has got a provision for putting a coin cell battery if you are making the system standalone. And apart from that, you have got the debugging options, like you can place a logic analyzer or simplicity connector or ARM core site debug header is also being provided for ARM related debugging stuff. And it has got an onboard humidity and temperature sensor which is being interfaced via I2C protocol. So this you can use to test the I2C of your target MCU as well. So these are some of the basic information about the board that we are going to use. If you are interested, I'll drop the link to this document in the description. You can go through it. And the third and most major part is going through the schematic. So I'll give a brief about how to go through the schematic of any document, or for that matter of any board. So schematic is very important for any board, because if you are going to develop an application, you need to at least know for which pin which component is being connected. So for example, let us go to the user interface section. So yeah, so if you see here we have something called relative humidity and temperature sensor. If I want to use relative humidity and temperature sensor, how would I know to which pin it is being connected? So what you have to do is, you can see here sensor I2C SCL and sensor I2C SDL. So if you can know where these pins are going, you will know which microcontroller is controlling them. So if you see, it went to the shared connections, which is being connected to the expansion headers, and from there it is being connected to the radio 45.0, and radio 45.0 is being coming from the upper and lower connector of the board. So what is this upper and lower connector? So whatever the things you are seeing here, upper and lower connector, those pins that is being referred here. So from this, what you can know is, what are the RST sensor which is present on board, that is being interfaced by the target MCU. So you can use the RST sensor to test the I2C lines of your target MCU. So in this way, you can use schematic to know many things. So some of the symbols that you must know is, this is known as off-page connector. Uh, so this is used to connect schematics which are not in this page. Like if you have something like which is going out of the page, you will keep this, or which is coming into the page, you will give the another thing like input and output. You can refer to them as like that. So if you want to know which pin is connected there, you can simply copy it and search for it. So this is the way to read schematics. If you have any doubts, you can drop in comment section. So this is all about the introduction about the boards and everything. If you have any doubts regarding this video, or have any suggestions for the forthcoming videos, you can drop in the comment section. And if you find this video informative, please do like, share and subscribe to my channel Tech Talks. Thank you for watching.